Okay, today what we are going to do is we are going to find radius of curvature of planar convex lens using Newton's rings method. Now the setup that we have is we have a monochromatic source of light which we use sodium vapor lamp. Then we have a reflecting glass plate, and these rays are directed on a plain glass plate and this planar convex lens. So this planar convex lens sits on the top of this plain glass plate. Now there is a thin air film which is formed between these two, and because of this thin air film we observe such pattern when we look through the microscope. Now these are known as Newton's rings. Now we can just look at the setup that we have. So here at the bottom we have placed this planar convex lens and the glass plate. Okay, this is the reflecting glass plate which is at 45 degrees, and this is the microscope, and this is the sodium vapor lamp which we are using as the source of light. Now the formula which we use to find this radius of curvature, we have derived this in class. Dn square is 4n lambda r. Okay, so dn is the diameter of nth ring, n is the ring number, lambda is the wavelength of light, and r is the radius of curvature. So we are going to use this formula to calculate r, and for that what we need to do is we need to measure diameter of different dark rings. Okay, so you just look at this through the microscope and you see if you can see the pattern. It's not very clear, but we see such pattern. Okay, like this when we look through the microscope. Now if I want to measure diameter of this particular, let's say this ring. Okay, now before we go ahead, how do we count the rings? Now when you look through the microscope, you can see this central spot. Whether it's bright or dark, you will count that as 0. Okay, then whichever next dark ring that you see, that will be your first dark ring, this will be your second dark ring, this will be your third dark ring. This is how you will count the rings. Now if I want to measure diameter of this ring, what we usually do is we measure position of this point, and then subtract these two numbers to get the diameter. So this is what we are going to do in the experiment. We are going to measure position of this point and measure position of this point, and then subtract these two numbers to get the diameter of this particular ring. And to measure the diameter, we are going to use this vernier scale. Okay, so the least count of this there is a traveling microscope. So here is what is this is known as mean scale. So if you see, the smallest division on this scale is 1 mm, and this is the head scale. And if you see the head scale, you can see the numbers up to 100, 0 to 100. So there are 100 divisions on this scale. So the least count of this instrument that we have is 1 mm by 100. So the least count is 0.01 mm. Okay, so this is the least count of this instrument. Now the wavelength of this light source is given as 593 angstrom. Okay, so we will use this, and now what we want to do is we want to measure diameter of different rings, and we start from, so if you look at the observation table, we measure diameter of different rings. So the rings that we choose as 12th, 10th, 8th, 6th and 4th. So we will measure diameter of these rings. Okay. Now what we do is we will first go to the 12th ring. Okay. So what you have to do is now there are different controls, okay, on this instrument. This you can use to focus. Okay. This also helps in focusing. This knob, it moves the microscope back and forth, and now this knob, it moves the microscope horizontally. So once we get the rings like what you can see over here, like this, then what you need to do is you need to move this and go to the left hand side Okay, so left hand side of this central spot. So you have to go to the left hand side. So there will be rings like this, and you have to go to the 12th dark ring on the left hand side. And what we have to do is, you may notice there is a crosswire which is like a plus sign when you look through the microscope. So you have to bring the vertical line of the crosswire and have it overlapping on the 12th dark ring. It shouldn't be tangent, it should be exactly on the 12th dark ring. Now once you are at this position, okay, what you have to do is you have to record this scale. Okay, so for that, so first thing you need to do is you need to read this what we call as the mean scale. Okay, so now if you see this 0, okay, so you have to see which line this 0 has crossed, okay, on this scale. That will give you the mean scale reading, and which line of this scale, okay, coincides with this. Now here this is lying between 84 and 85, so you not write 84.5, you either write 84 or 85. Okay, so now here if you see this, you can just make it out that this has just in, if you see this, this is just below 39 mm. Okay, I'll try to focus it. Okay, so now I'll get for the 12th dark ring, I'm on the left hand side, so my main scale reading will be 39 mm. My head scale reading is 84 multiplied by least count 0.01, so I will add this, so I will get total reading as 39.84 mm. Now next thing what that I need to do is, now I will move this, okay, move this microscope using this knob towards the 10th dark ring and have it overlap. So this vertical line should overlap this, and again I will read this, okay, this mean scale, and I will read the head scale. Okay, so we will go on measuring the positions of 12th, 10th, then 8th, then 6th and 4th on the left hand side. Okay, so you will first fill this column, so 12th, 10th, 8th, 6th and 4th, you write these numbers on the left hand side. Then what you will do is you will first move to the 4th dark ring on the right hand side and record its position. So you will first record this 4th on the right, okay, then you will measure 6th, 8th, 10th and 12th. So the important thing is your microscope should move in one direction. So this will be 6th, 8th, 10th and 12th. Okay, you shouldn't move it back and forth, it should move in one direction. Now once you have these, okay, there is one important clue to check whether your readings are correct or not. See, when we scan the rings from left to right, okay, actually physically what is happening is this microscope is moving from right to left. Okay, so what it means that your readings should go on decreasing gradually. So the position reading for this will be less than this will be less than this, like this it will decrease. Then for this reading, this will be less than this, and as you go up the reading should go on decreasing. If you find one of the readings is more than this, then you should understand that something is wrong with your readings. So once you get these values, you subtract these numbers to get the diameter of these rings, you square them, and then you divide these numbers by a particular ring number. You will ideally get a constant value. Then find the mean of this and then use this value in this formula to calculate the radius of curvature. Now understand that this is in millimeter square, so you should have lambda also in millimeters, and then do calculations in millimeters and then find R. Okay, this is for the readings. Okay, so this is how you will find radius of curvature of a plane convex lens. In error analysis, what you have to do is you have measured 5 diameters, so you have to calculate 5 values of R using this formula, and then you have to calculate error in all these 5 values using this formula. Here delta D is the error in least count of your instrument. Okay, so this will give you the error in each of these values.